colleague, students, please report to student services, Julia Sierra, Alejandro Herrera Sanchez, and Batista, Jason Batista.
Please report to student services.
Oh, you're right. He's smart.
She was like, "Gotta do it."
Yeah, she was about to. I just saved you.
I love it. Chicken.
What the?
You're the worst.
Just stop by, grab what you need, please.
Probably. Honestly, probably so. You throwing stuff in?
What? Oh, it's probably a secret.
Also, something.
What is
Is
it?
it failed drawing?
Yeah.
Yeah.
What does it look like? These are his eyes and that's his mouth.
Is this gonna taste good?
Well, that was magic pills, I know.
Ooh.
That pause didn't seem too good.
Oh.
I'm kind of dry.
Don't say anything.
Oh,
Okay, well, it was a plastic wrapped donut, so.
well, you're right, but like, I didn't expect it to be this dry. It's like scrunchy. It's like starch. I don't know.
Get your computer.
There's nothing you I want.
You are a slacker.
Is this Mr. Brandon hair?
Yeah.
I knew it.
And
Really?
piercings.
Give me the dot line.
I knew it, bro. And it's
And a better.
and a
It
better
is
top.
But I had to explain what my mom meeting was, too.
Oh my god, so nice. And like, she just doesn't get it. She just goes, "You kids are stupid."
And then she asked me what skinny was. I was like,
I
don't know.
I was talking with my friend and we were playing a game. And I was on the headset, so like, she couldn't hear me. But I said something about skipping toilet, and then she went this full rant. I shouldn't say that. Because back in the Roman Empire, they would stick people's heads in toilets, and that was a form of torture, and that's what skipping toilet. And I said,
Good morning, ladies and gentlemen. How are we doing today?
she was like, "No."
Good, wonderful, excellent, amazing, ladies and gentlemen. Take out your periodic tables. Take out that solubility chart and get your computers logged in so that you can go to the Pear Deck to log in and start answering some questions. There is the info on the Pear Deck, ladies and gentlemen.
Wait, what am I doing? This one?
All right.
Oh, did you already email those teachers about a reference? Because I found out it's not a recommendation. It's like Sanskrit. It's like they get sent a Google form and like they have to like rate you on scale of like 1 to 5. But like it's not a letter. Like they don't have to write anything.
Yeah.
Huh?
Leave.
I know. I'm telling you because I didn't know that either. It's like they get sent.
Nadia.
They get sent a form and it's like how responsible is Levi on a scale of 1 to 5. How
Yeah.
dependable is Levi?
Roll seal.
Okay,
Savannah. Ridley. Brenda. Nice one.
why can't you just trust me?
Jacqueline.
There's no point though. You're honestly not even better.
Danielle. All right, ladies and gentlemen. So let's take a look at your quizzes real quick for you. Let's go over what will be the correct answers on them, and then we will get into our Pear Deck for today, ladies and gentlemen.
Oh my god. No, I keep entering my password.
What kind of Monday is that?
Okay, so
If you're sick, it's always bad.
Hello, Adrian. How are you? Wonderful. And let's go next door right away after you set your stuff down and do the quiz from Friday. So go ahead and set your stuff down at your desk.
You know, one of these days it's gonna light up my mouth.
I
Why
don't know
would your
why.
mouth be all the way down there?
I don't know, but I just know. What is it?
That's not mine.
Why would you get one wrong and I'd get it for her grade? That doesn't make sense.
I forgot to reduce.
Oh,
Loser alert.
I was
Loser alert.
gonna say like,
This
this is literally paper right now.
Who?
My paper. If I didn't study, this would have been my paper.
It didn't sound like you said your name.
I didn't study actually. Nadia put me on.
I don't want it.
Nadia, I got a paper grade.
Okay.
What are you bragging about? There's no one cares. Did you guys cheat?
Okay. So for the first one, ladies and gentlemen, there is how to balance it. Questions.
Yeah.
Oh, shoot.
I didn't know that. You could do it in the sun.
But I don't know how to do it.
Second one. There's your numbers to balance it. Questions.
It took me forever to do this.
And you did it wrong.
I did get it
Then
right.
you're bad.
I just, it took me a while.
Again, if you start with something that you have to balance, what I mean by that is either start with the aluminum, because there are two of them over here and there's only one of them over here and there's only one way to do that. Also the sulfur. There are three sulfurs over here, there's one over here. So if you start with those things, that gets you these two numbers, then the only thing left is to balance this one. Okay? So when we say start with one where there's only way to balance it, what that means is there's only aluminum here and here. The only thing I can do to get two aluminums on this side is put this number out in front. Only way I can get it to balance. Same thing with the sulfur. Because there are three of them here, I have to put a 3 out in front here. If you start with those things, then it kind of works out for you in the end because there's only a few things left for you to balance. Okay? And if I were to change this here, I would have to change both of these. So that's why it is what it is. Okay? It is what it is. Questions? All right. All right. All right, Isha, set your stuff down and we'll put you next door to get that quiz from last week Friday.
Oh, yeah.
So if you want a periodic table, you can bring it, but if you don't have any notes on it, it probably isn't going to be helpful. Whatever happened to no eating in a science room?
I forgot that.
We should probably kick her out.
Think you should?
Yeah.
Okay, go eat out in the hall.
Bye.
I'm done.
You're done?
Yeah.
You're done? You're done?
Yeah.
I don't have a pen.
I got one over here for you.
He's gonna fail you now.
I should. I should.
Okay, let's go. Actually, let's not schedule yet. 'Cause I don't know when I'm gonna retake my test.
I'm just gonna spring on you. You're not a girl.
You're a dummy?
Yeah.
I'm gonna call Joe Biden.
Need anything else? Let me know.
He's gonna come down.
He's gonna forget where he's going.
Right.
All right.
He's a
So there you go, ladies and gentlemen. There is your third and your fourth ones for balancing. All right. Okay. Any questions on 3 or 4? And those are the answers at the bottom for the problem on the back of your periodic table, or the back of the quiz.
I thought I was understanding that. I didn't know he was like, no, that sounds stupid.
All right. Any questions, ladies and gentlemen? All right. Please remember, this week, Thursday, is the last day that I will accept any missing work from you. And again, if you were to have wanted to do a retake on a quiz, I'm sorry, not on a quiz, on a test for Unit 3, has to be done before Thursday, ladies and gentlemen. Okay? If you have study hall during the day, you could come in and take it during the day on Thursday, but otherwise, if you're going to do it before or after school, I will not be around Thursday after school. And I will not be around Thursday morning. So that limits you to tomorrow, today after school, and Friday and Wednesday. Sorry, not Friday. So please keep that in mind. Questions? All right. I asked you to turn your computers on and go to this Pear Deck. There are 5 of you who are connected. So let's go, ladies and gentlemen. WCCGBR is the code that you need. Okay. All right. Today we're going to talk about the last type of reactions that we are going to talk about, which are double replacement reactions. To do that, we're going to talk about something called predicting precipitates. Okay. And then again, on the bottom is the reminder that the last day for retakes is this Thursday. Here is the schedule for final exams for next week. So if you want to take a picture of this, you are welcome to, but your final exam in here is on Wednesday, the 28th, from 7:30 in the morning till 9 o'clock, and you will be doing a lab during that time that will take the place of your final exam. Okay? So, questions? All right. So, which of the following metals would have a reaction with cobalt chloride? So which of the following metals would actually replace cobalt in this particular reaction if it were a single replacement? So look at your list, ladies and gentlemen. Find the one that you think would replace cobalt and move your icon on top of it, please. Very nicely done, ladies and gentlemen. You almost got them all lined up, too. That is pretty impressive. Pretty impressive. Okay? And the best part is, what's even more impressive is you picked the correct answer, ladies and gentlemen. Aluminum is the one that is on the list that will replace cobalt in cobalt chloride because it is the only one that is higher up on your list, ladies and gentlemen. Good, 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 good. All right, which of these would replace barium in the barium nitrate? So again, you've got different metals there. Which one would replace barium in barium nitrate? Move your icon on top of the one that it is, please. What's that? Okay, so which one of these is above it? So where should your icon be? Not on any of them. Not on any of them. None of them will replace it. None of them would have a reaction with barium nitrate. Barium nitrate is too reactive. You're right, there are only 2 things on this list that are more reactive, lithium, potassium, and that was not one of your choices. Good. How about iron chlorate? Which one of these would react with iron chlorate, ladies and gentlemen? Everybody's going with chromium because chromium is the correct answer, ladies and gentlemen. Very good, very good, very good. All right, last one. Which of these would react with barium iodide? Good. Potassium, ladies and gentlemen. Now, again, this is something too that you have. I have to explain to students all the time. Questions like this on a quiz, people will be like, "Well, you asked the same question on the quiz twice, Mr. Brink." I may have asked the same question twice, but did I give you the same answers twice? So the first time I gave you a barium compound, there was no correct answer. None of them would replace it. Here I gave you a similar question, but now I gave you one that actually would replace it. So always make sure that everything, and I'm not saying there are times where I do have the same question on a test. Absolutely. But sometimes the choices are different. So questions, ladies and gentlemen? All right. Before we get into going through things today, one of the things that I should do occasionally, and I will do right now, is are there any problems on the worksheets in the packets that I've given you or whatever that you would like me to go over, that you would like me to do for you? Because you're either having trouble writing them or balancing them or something like that. So is there any on the worksheet? Is there any on the predicting single replacement reactions that you would like me to go over and show you how to do? Yes. I missed one on the answer key. For which one?
After 20, it's the fourth one.
It's the which one?
Fourth.
So the one that says aqueous magnesium hydroxide and ammonium phosphate are mixed together and and a precipitate of magnesium phosphate is formed as well as some ammonia. Okay. All right. So I don't have that one on the answer key. All right. I will go and I will get that one on the answer key. But for now, let's try and do this, ladies and gentlemen. Okay. Let's try to do this one. All right. So again, ladies and gentlemen, you've got to be able to write compounds. If you can't write compounds, you are going to struggle in this course from here on out. And this is an example of being able to write a compounds, ladies and gentlemen. All right. Magnesium hydroxide. Magnesium is Mg. It is a +2. Hydroxide is OH, and it is a -1. So therefore, ladies and gentlemen, we are going to do the crisscross method, and our compound will become Mg parenthesis OH2. And now it says it is aqueous. That means we're going to put AQ by it. Okay? And ammonium phosphate. Well, ammonium is NH4, and it is a +1. It is the only positive polyatomic on the back of your sheet. Phosphate is PO4, and it is a -3. So when we do this one, we're going to have NH4, 3, PO4, and it is also going to be aqueous. Okay? Now, we have not gotten into writing these reactions yet, doing these. This is the type that we are going to talk about today. This is what is called a double replacement reaction. And the reason for that is on the reactant side, you have two compounds. If it were single replacement, you would have a compound and an element, but we've got two compounds. So this one, however, actually, sorry, when I look at this, this is not a double replacement because there are three products here. Okay? So I do give you all of the products that are formed. Magnesium phosphate is formed. Okay? So that means I'm going to take this magnesium here, still a +2, and I'm going to put it with phosphate, which is still a -3. So then I'm going to get Mg3, PO4 in parentheses, and a 2 after it. And it is a precipitate. So we indicate a precipitate with the letter S because our definition of a precipitate is a solid that settles out of solution. We're also going to get some ammonia, better known as nitrogen trihydride. Nitrogen trihydride is a covalent compound, ladies and gentlemen. So we write N, we do H, and we put a 3 after it because that's the trihydride. Now, I did not give you the state for nitrogen trihydride, so you wouldn't actually know what to put down here. And then water. And hopefully, ladies and gentlemen, you know how to write the formula for water, H2O, and it would be a liquid. Okay? Water is one of the few substances that actually comes out as a liquid. Now, aqueous is different than liquid. Aqueous means it is dissolved in water. Water as a product means that it is actually a liquid, or if it was hot enough, it could be a gas. So now, ladies and gentlemen, we list everything that is involved. Mg, O, H, N, and P. Now, normally I would tell you, yes, go ahead.
There are 3 by the H in parentheses because the nitrogen is a -3 charge.
No, because this is a covalent compound,
So you don't press.
so you don't do the charges. Okay? So anytime you see these prefixes, that means it's a covalent compound. That means it does not have charges. Okay? But thank you for pointing that out, because again, I should have said that. When we're doing a covalent compound, we don't worry about charges. Okay? So over here, I've got 1 magnesium. Over here, I've got 3. Oxygen is going to be a pain in the butt here, because I have 2 oxygens here. I have 4 oxygens here. That means I have 6. I have 8 oxygens here, and I have 1 oxygen here, which means I'm going to have 9. And unlike before, I can't ignore it. It's not in every compound, so I can't simply ignore it like I tried to do before. Hydrogens are also going to be a bit of a pain, because I have 2 of them here. I have 12 of them here for a total of 14. And on this side, I have 3, might as well stay consistent. 3 hydrogens here and 2 hydrogens here for a total of 5. Nitrogens, I have 3 of them here. Why? Because the 3 outside the parentheses distributes out to the 1 inside. And I have 1 of them here. Phosphorus, I have 1 PO4 group here, and I have 2 PO4 groups here. Okay? So now I've got everything listed. What I'm now going to start doing is balancing things that there's only one way to balance. Those things include the magnesium and the phosphorus and the nitrogen. Those are the 3 things that there is only one way to get them to balance, because they only appear in one spot on each side of the equation. So I'm going to start with magnesium. I'm going to put a 3 in front here. Now, that changes the amount of magnesium, but it also changes the amount of oxygen to 6 and hydrogen to 6, which I then need to go back and add to this 4 here. That gives me a total of 10. 6 hydrogens here plus the 12 here. That gives me a total of 18. And that is why I like to put these down below or up above. Because then when I change them, if I have it written up above, it reminds me it's somewhere else on this side. Add it to that number. Okay? Now I'm going to balance off the nitrogen. I have to put a 3 in front of the nitrogen on the product side. It's the only way for me to get 3 of them. Have to. No ifs, ands, or buts. But that also means that now I'm up to 9 hydrogens, and the 2 there, I'm up to 11. Next, I'm going to balance off the phosphate. Since there's 2 of them on the product side, I'm going to put a 2 over here. Okay? So that's now going to make this 6. That's now going to make this 24 hydrogens. 24 and 6 is 30. I'm going to have 2 phosphorus. And I'm going to have 8 oxygens here to go with the 6 here. That is now 14. And what sucks here is that I had nitrogen balanced. And now it unbalanced. There's nothing I can do about that. Nothing I can do about that. So now I'm going to go back and I'm going to rebalance the nitrogen, because I have to. It makes more sense than trying to balance off the oxygen or hydrogen. Those are tied up together here. In the end, I should be able to put one number in front here and get everything to balance. But to do that, ladies and gentlemen, first I need to take and get rid of this 3 and make it into a 6. So now I have 6 nitrogens. By the way, remember, there's only 1 nitrogen here. So I put a 3 there before, it made it 3. I put a 6 there, now it makes it 6. Okay? So it also changes the hydrogens to 18. which means this is now 18, ladies and gentlemen. Okay? Now, balancing off hydrogen or oxygen, neither one is very easy here. Okay? Because they're all tied up in a lot of places. But I'm going to try to balance off the hydrogen. For what did I do? Oh, thank you. Sorry. Very good. Thank you. 20. Okay? So I do have 18 here, though. And what number plus 18 is going to give me 30? 12. So I need to get to 12 hydrogens here. The only way that happens is if I put a 6 there. So now I'm up to 30 hydrogens, which is good because that's balanced. I'm now up to 6 oxygens here, plus the 8 oxygens there. Again, everything has to work out in the end if you wrote all your formulas correctly. Questions? Now, where the problem comes in, ladies and gentlemen, is if you don't get these charges right, you're not going to get Mg3PO42 here. So if you forget this 2 or this 3, you're probably not getting this equation to balance. It's probably not going to work out. The same way here, if you put the 2 next to the H and don't put the parentheses, you're probably not going to get this to balance. So if you're working on it and working on it and working on it and it's not working out, the one thing I would tell you, go back and check and make sure you wrote correct compounds. Because if you haven't, it's probably not going to balance in the end. Okay? It's probably not going to balance in the end. Questions? Yes? No? Maybe so. Anything on this? Any others on there that you would like to see me do or work through with you or anything like that? All right, ladies and gentlemen, then let's talk about double replacement reactions. Okay? A double replacement reaction is a reaction in which 2 compounds would exchange cations, the positively charged ions, to create 2 new compounds. Okay? So that is what a double replacement reaction is. You have 2 compounds on the reactant side, you have 2 compounds on the product side. General formula is AB plus CD produces AD plus CB. If you are looking at this and thinking, why suddenly did he change the order here alphabetically? Why is C in front of B here? Cations are always written first. So your cations are A and C in this reaction. They are always the beginning part of your compound. And since this has to be 2 compounds creating 2 new compounds, A and C have to stay first in your compounds. And then the D and the B, you can either say A and C are switching spots or B and D. It doesn't really matter. Okay? It doesn't really matter. Okay? So last week we showed you a single replacement reaction with Cynthia. Right? Good. Get up, Nero.
No.
Here you go.
No.
Now we just did a double replacement reaction. Why? And what's the compound? Nero has the clicker. I now have his computer in his desk. Okay, go ahead.
No, okay. I think you got this.
You can't hit the button to advance?
I don't want to hit the button to advance.
Why not? You want to stay where you are? You don't want to advance?
Yeah, no, actually, I kind of like this slide.
All right. Here you had the power. Chose not to keep it. Chose to get rid of it. Okay. So here is a double replacement reaction, ladies and gentlemen. What's AgNO3? Good, something. You have named compounds. Come on.
Glad we got there.
Silver nitrate. Silver nitrate. What's NaCl? Sodium chloride, which is actually what? Table salt. So these are two compounds that are both aqueous. This one I showed you last week. This was the one here that we put in with the copper wire. Silver nitrate, okay? If you put it in with table salt, you will get a chemical reaction. Now, it is not just enough that these things switch places, so that the sodium is now with the nitrate and the silver is now with the chlorine. The reason that a reaction actually occurs is right here, ladies and gentlemen, this. This is a precipitate. The term S means a solid that settles out of a solution, a solid that will not be dissolved anymore. When you have a solid that settles out of solution, you actually have, ladies and gentlemen, a chemical reaction. If everything stayed aqueous, there would be no chemical reaction. So you have to find this, what we call precipitate. Okay? You have to find it, ladies and gentlemen. Now the question is, how do you find it? Take out that pink sheet that we were working with for the single replacement reactions, ladies and gentlemen, and turn it over. Okay? Now, the other side of that sheet is a little bit more difficult to use than the side that we had been looking at. Okay? This side of the sheet is a little bit more difficult. Not impossible, but just a little bit more difficult. So let's take a look at it, ladies and gentlemen. I need to back up here on my Zoom. Okay? All right. Now, this table is divided into 3 sections. That's why there are 3 separate tables on here. The table at the top deals with 2 different anions. Anions are the negative part of your compound. Depending on what your anions are, ladies and gentlemen, will determine if you have a precipitate with a certain cation. Okay? So first of all, I will never give you anything that is not on this list. If I do, I have to tell you if there's a precipitate and what it is. But from this list, you can find precipitates. Now, the way we look at this top section here, ladies and gentlemen, is there are anions, there is what normally happens, and then there are exceptions. Okay? With nitrate and chlorate, if they are your anions, ladies and gentlemen, there are no common cations that we know of that will cause them to make a precipitate, that will make them become a solid and settle out of solution. These are kind of universal anions that always are aqueous, no matter what you put them with. No matter what you put them with, they will always be aqueous. So up at the top here, I put that next to this part of the table. Always aqueous. It would be a good idea for you to put that by that part of the table. Because anytime you have a compound with nitrate or chlorate, it will always be aqueous. Now what this also allows us to do is put something that would normally precipitate with one of those, and it will not. So you can make this your reactants that you're putting together. Okay? So the first part of the table, no matter what these are with, they are always going to be aqueous. Always. Never be a precipitate. Now, that means that if your products have these two things in them, you have no reaction. Because if you don't find a precipitate, there is no reaction in the chemical in a double replacement reaction. Okay? So just like we said, if the metal isn't more reactive than the other one in a single replacement, we would write down no reaction. You can do the same thing here. There are times where there will be no reaction. Leave. As long as you think you understand this, because this is kind of important. Okay? Then you have the middle section here. These things are normally aqueous, will normally precipitate. So acetate, chloride, bromide, iodide, sulfate, and chromate. These things will normally be aqueous, unless they happen to be with these few exceptions. If they're with one of these things, now they are going to become a precipitate. Now they are going to settle out. And in that last example that I gave you, silver and chlorine were the precipitate, and that is why that reaction occurred. You will create a solid material that will literally settle out of your solution. We will show you that in a couple of minutes. Okay? So next to this part of the table, I have normally aqueous, because those things normally are aqueous with most things they're with. But with exceptions, with these things, they will be a solid. Okay? So that's how we read the table. Up here, always aqueous. In here, normally aqueous unless they're with these things. And if you'll notice, a lot of these things are the same throughout. Silver is in all of these exceptions. Lead is in almost all of the exceptions. This mercury is in a few of them, and then down here you got barium, strontium, and calcium. So the same things cause the exceptions, basically. Questions? All right. Then there is the bottom part of this table, ladies and gentlemen. Now, the bottom part of this table says these few anions, sulfur with sulfide, hydroxide, carbonate, and phosphate. These things are almost always a precipitate. These things, when you put them with almost anything, they will precipitate, except a few exceptions. Now, here's the weird part of the exceptions. First of all, ammonia. Ammonia is always an exception with these. You put these with ammonia, it'll still stay aqueous. Okay? But the other one is here where it says cations of group 1 and 2. What we mean by cations of group 1 and 2, ladies and gentlemen, is from lithium and beryllium all the way down to francium and radium. Those are the cations of columns 1 and 2. Lithium, sodium, potassium, rubidium, cesium, and francium. Well, hydrogen is not a metal. So it reacts like a metal and a non-metal. Okay? So, no, it's not going to be in here. Okay? Beryllium, magnesium, calcium, strontium, barium, and radium. By the way, I should point out that if hydrogen is with these, is it going to make a precipitate with this? What's it going to make? Water. If you put it with this, what's it make? Hydrosulfuric acid. By definition, hydrosulfuric acid needs to be aqueous. Carbonic acid. Phosphoric acid. So if you put hydrogen with these, no, it will not precipitate because it has to be aqueous because it's an acid. Okay? Now, for these last two, take out the cations of column 2. They only are exceptions with the cations of column 1, and there's a double exception there, except lithium. So if they are with lithium, they still will be a precipitate. Okay? So these are the exceptions, and there's an exception to the exceptions. Boy, that makes it wonderful, doesn't it? Okay?
Choose to do this to your son?
What?
Why did you choose to do this to your son?
I didn't. This is just the way science was. Okay? I can't control that. Okay? So these things down here are normally a solid. They will almost always be a solid, unless they're with the exceptions, and then they're going to be aqueous. So that is how we use this table, ladies and gentlemen. Okay? That is how we use this table. So keep this table out for a second, ladies and gentlemen. Okay? All right. How do we identify a double replacement reaction? 2 compounds on each side of the equation. Always 2 compounds. Okay? All right. Now, technically, ladies and gentlemen, there are 2 other ways that will tell you that a double replacement reaction has occurred. Water might be one of the products. If water is one of the products, that reaction will occur. So if water is one of the products, that reaction will occur. The reason for this one, ladies and gentlemen, is this is what would happen with the neutralization of an acid and a base. It's a double replacement reaction, and you create a salt, which is aqueous, but you also create water, which means the reaction actually occurs. Okay? And then the second one, ladies and gentlemen, and this doesn't happen very often, but if a gas is produced, if one of your products goes to a gas, a precipitate would go to the bottom and settle, a gas would go off into the environment, but they mean that a reaction has occurred. Okay? They mean that a reaction has occurred. So let's take a look at something here, ladies and gentlemen. This is sodium iodide. Okay? This, ladies and gentlemen, is lead 2 nitrate. Describe them, basically. Little yellow tint to it, yes. 2 clear solutions, though. Okay? You can see through them. One has a slight yellowish tint to it. Taken. No odor. No odor. Okay, I only get 1 shot at this, ladies and gentlemen, so pay close attention. Are you ready?
Am I going to change colors?
Is that a chemical reaction? Unexpected color change, correct? Okay, 2 clear solutions, bright yellow solution when you're done. Actually, that is not a bright yellow solution. Actually, that is a bright yellow precipitate in a solution. That is a yellow powdery substance that we're going to let sit here, and it's going to go sit on the bottom of the container. And then over time, the top will become clear again. That is what we mean by a precipitate, a solid that will settle out of solution. A solid that's going to go sit on the bottom of that container that we can then filter away from what is in there. By the way, this is a lab that you're going to do in the second trimester. Or second trimester. Exact same reaction that we just did. And then you are going to recover all of the precipitate that was created in this lab. Okay? Can you touch it? Sure you can. It's lead, though. I would wash your hands afterwards. Because lead is kind of a poisonous heavy metal.
It looks like banana flavor.
It looks
Banana
really,
flavor?
is it thick?
Is it
Did it
thick?
become really thick?
No. What you're seeing, though, is you're seeing the particles being suspended for now.
It kind of looks like you crushed up a bunch of happy crunch.
Kind of like this, ladies and gentlemen. This is water and sand. Now, they don't mix. The sand is settled to the bottom. But if you look at the top of the sand, what do you kind of notice? There's a few layers there. And the top layer, how does it compare to the bottom? Take out your headphone. Come on, you know you're not supposed to have it.
Your voice. Go.
So what do you notice about the top layer compared to the stuff on the bottom? Anybody? The top layer is a lot more fine particles, ladies and gentlemen. Okay? So what's going on in there right now, ladies and gentlemen, is this. When I shake this, everything becomes mixed throughout. But when I stop shaking it, what do you notice on the bottom? It settles out. Now the heavy particles are sitting there already. But this isn't clear. Why?
Because they're still tiny particles.
Those are the lighter, those are the smaller ones that were sitting on top of there a little while ago. Those are going to take longer to settle down to the bottom than the heavier ones did. Okay? So the sand that is in there, the heavy particles go and settle down first because I stopped shaking it. The light particles take a little longer. Here, they're all the same mass. So they're all going to take a little bit longer to go to the bottom and settle out. We'll leave that sit there for a while so that you can see that happening. But without that precipitate, that stays clear. And we don't know if anything actually happened. Nothing may have happened. You could mix two chemicals together and nothing happens. They just mix together. They don't change. That's why we have to find a precipitate. A precipitate tells us that they have changed, ladies and gentlemen. A precipitate tells us that they are different, that they are not the same as what they were before. No precipitate, no reaction. All right, so we went through this, ladies and gentlemen. So if you put Mg, magnesium, with nitrate, here's nitrate. All of them are aqueous. That means it's going to be aqueous. If you put silver with chlorate, it is going to be aqueous. It will dissolve. If you put silver with acetate here, because it's one of the exceptions, now it will make a precipitate. So instead of putting an AQ by it, we're going to put an S by it. S means a solid. S means a precipitate. It means if that is one of your products in the reaction, your reaction actually occurred. If we put potassium with that acetate, nothing happens. It stays aqueous. Okay? If we put lead with iodine, we get a precipitate. That is the precipitate that you are seeing in there, ladies and gentlemen. Well, what color is lead iodide? Bright yellow. Bright yellow. Solid that's settling out to the bottom. If we had put magnesium in there, guess what? Nothing would have happened. Nothing would have happened. The two solutions would have mixed together. There would have been nothing that we saw happen. If we put aluminum with sulfate, here's SO4. Aluminum is not one of the exceptions, so it stays aqueous. This was magnesium with iodine. It was not one of the exceptions, so it stays aqueous. Barium with sulfate. Here's SO4. Here's barium. Now it will be a precipitate, ladies and gentlemen. Instead of dissolving, being aqueous, which most of them will, the exception says it will make a solid. Questions? Magnesium with sulfur, though. Okay? Magnesium with sulfur still stays aqueous. Why? Magnesium is in column 2 of the periodic table. It is one of the cations of column 2 right here, so it's going to stay aqueous. Put silver with sulfur. It's not in columns 1 and 2. It's over here. Makes a precipitate. Put tin with hydroxide. Tin is over here in group 14. It will precipitate. It will make a solid. Put strontium with the hydroxide. Strontium is in group 2 of the periodic table. It will stay aqueous. Put lead with PO4. Lead is here in group 14. Therefore, it will make a precipitate. Put ammonium with PO4. Stays aqueous. Put sodium with carbonate. Stays aqueous. Why? Sodium is in column 1. Put lithium with carbonate, though, you get a precipitate. Why? Lithium is an exception to the rule of the cations of column 1. So it actually makes a solid again. Questions, ladies and gentlemen? Yes.
On the notes, so first one is a solid. And then
Up there?
Yeah, and then the second one is aqueous.
Okay, please change that. Sorry. So you're saying I have the notes wrong. What a shocker. I know. Don't say a word. Okay? So I have them in the wrong spots. Please correct it. Check to make sure they are correct in your notes. Okay, good. At least I made that because apparently I must not have changed your notebook before I realized it was wrong.
You should apologize.
What?
You should apologize.
I just did. I said I'm sorry.
I did not sound.
Or he just apologized.
Wait, you
Take what you can get.
Sorry.
Take what you can get.
I'll
Okay?
take what I have.
Okay? I don't hear you guys apologizing for me having to grade some of your tests when they're not very good. I'm kidding. I'm kidding.
I don't appreciate that you looked at me.
Actually, to be honest, it's easier to grade your tests when they're not very good because when you don't put anything on there, I put an X on the page 0 and move on.
I feel like that was a little locked and loaded.
Shoe fits sometimes. Never mind.
Do you think it's better to grade tests when it's like from a smart student?
I saw.
No, I don't think it's funner. I think it's more rewarding to me because it means, okay, you understood what I said. And when you leave a whole page blank, that is one of the most disappointing things for me, but it's also the easiest for me to grade. So I can't give you any points if you don't try something. So
Would you rather a blank page or a page that you have to fill out and still fail?
I would rather be able to give you some points for what you know.
So you would
I think when you skip a page, it's a cop out. You're saying, "Oh, I don't understand anything." Really, you can't put anything down.
so
Anything?
basically if we try the equation you get like at least
Well, you still have to do some correct work, but I'm just saying, I think you could do something
right, like if you understand the format.
correct.
Yeah.
You're
Correct.
saying to appreciate my hashtag.
All right. So, what would be the products of this reaction, ladies and gentlemen? If we were to take lead nitrate and mix it with sodium chloride, what would we get? What's changing places with what? What? The lead and the sodium. And again, I don't care which one you write first on the product side. If you write the sodium compound first or the lead compound, that doesn't matter. They're both going to end up on this side. So one of the things that we would get, sorry, guess I need to fill it in because I didn't here. Okay, whoop, wrong way. Okay, so what's the charge of lead here, ladies and gentlemen? The charge of lead here is a +2. Very good. Okay, so if I put lead with chloride, what would be the formula? PbCl2. Okay, and then I would also get sodium with the nitrate. What's the charge on sodium? +1. What's the charge of nitrate? -1. So our compound would be NaNO3. Now, before I worry about balancing this, I need to see if there is a precipitate that forms. Well, here's what we know for sure. Anything with nitrate is not going to precipitate. It's going to be aqueous. So the question is, does lead with chlorine precipitate? It does. So therefore, ladies and gentlemen, this reaction occurs. So now we can take and we can balance it. To balance it, ladies and gentlemen, I'm going to use this as a shortcut this time.
Whatever.
One lead. 2 NO3 groups. Why? Because they're in parentheses and there is a 2 outside of them. 1 NO3 group over here. Why? No parentheses. 1 Na, 1 Na, 1 chlorine, 2 chlorines over here. Balance off the NO3. Going to put a 2 in front here. Gets that balanced. 2 there. Now I'm going to put a 2 in front of the NaCl. balance, balance, boom, you're done. Questions? The only reason you have to balance this is because the reaction actually occurred. If the reaction doesn't, you just write down no reaction and you move on. Questions? Oops. All right. So if magnesium sulfide and aluminum nitrate were to combine, were to be mixed, what would the possible products be? All right. What's the charge on aluminum? Aluminum is a +3. What's the charge on sulfur? So now I write the compound, which is? Okay, what would be the other product? Magnesium, what's its charge? +2. Nitrate, what's its charge? -1. Crisscross method gives us Mg, NO3 in parentheses, 2. I know this is going to be aqueous because anything with nitrate is. How about this one? Aluminum sulfide. Does aluminum sulfide precipitate? It does. It's the bottom part of your periodic table. It's the top one in the bottom section. Sulfur, since it is not with a cation of group 1 and 2, aluminum is in group 13, this precipitates. So now, ladies and gentlemen, we are going to balance it. Al, Mg, S, and NO3. The reason I'm leaving NO3 together in these, ladies and gentlemen, you could separate it into nitrogen and oxygen. But since it's NO3 over here and NO3 over here, they're exactly the same, I'm going to treat it as a group. 2 of these groups on one side, 1 on the other. 1 sulfur over here, 3 over here. 1 magnesium over here, 1 over here. 1 aluminum over here, 2 aluminums over here. That's 3 and the 3.
3 NO3.
3 NO3. Thank you. Sorry. Thank you very much, Miro. Okay? Now, you could start wherever you want, ladies and gentlemen. Where do you want to start balancing? Okay? So sulfur. How many do I need to put on this side? I need to put a 3 over here. I get 3 sulfur now, 3 magnesium. What do you want to do next? What?
Magnesium.
Okay, so magnesium. I need 3 of them on the product side, so I'm going to put a 3 in front of the compound containing magnesium. That gives me 3 of those. Now, how many nitrate groups? 6. Okay, what do you want to do next? Okay. So I've got 6 over here, 3 over here. What number times 3 will give me 6? 2. Makes for 6 of those. 2 of those. Boom. Everything is balanced. All right? Everything is balanced. Questions? Try the next one, ladies and gentlemen. What products are you going to get? Which one precipitates? What would the balanced equation look like? So what are the products that are created, ladies and gentlemen? What's changing places with what?
Magnesium, potassium.
What?
Magnesium and potassium.
Magnesium and what?
Potassium.
Okay, sorry, I thought you said calcium. Okay, so magnesium is going to switch place with the potassium. What does that give us?
Magnesium.
MgSO4. Mg is the +2. SO4 is the -2. So yes, when you crisscross them, you get MgSO4. Okay, what do we get when we put K +1 with NO3 -1? KNO3. I know this is going to be aqueous for sure because it's another NO3 compound. So how about the magnesium and the SO4? So what does that mean? No reaction. No reaction, ladies and gentlemen, and you are done. You don't have to balance it. Don't waste your time. This reaction doesn't occur. There's absolutely no reason to balance it, ladies and gentlemen. Questions? By the way, this is a preview of what you're going to do in your final exam. You are going to take two aqueous solutions. You are going to mix them together, and you're going to see if you get a reaction. Now, why are you doing that, ladies and gentlemen? Because you have to identify which of these two aqueous solutions is in which bottle that you are holding in your hands. So you are going to be given at the different lab stations, and there will be 6 of them set up. You're going to be given anywhere from 3 to 6 different solutions labeled A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, and you have to figure out what is in each bottle. Now, I will tell you what could be in the bottles, but you have to tell me where that is. Which bottle is it in? Is it in bottle A? Is it in bottle B? Is it in bottle C? Is it in bottle D? And you'll do so by figuring out, hey, you know what? This is supposed to give me a precipitate. So which 2 bottles, when I mixed them together, gave me a precipitate? Okay? That is what you're going to be doing. Questions? There is a worksheet online to practice double replacement reactions. If you have yet to finish the Unit 8 worksheet on just balancing equations or the one on single replacement reactions, you've got some time today to do any one of those that you wish, ladies and gentlemen. So the last 10 minutes of the class are yours, ladies and gentlemen. If you want to come up and take a look at our yellow stuff that is a lot darker now at the bottom than it is at the top because all of that solid is starting to settle out, you are welcome to. Go to work, ladies and gentlemen.
So, Brian,
Yes?
can I print out the worksheet?
Can you print it out? Where are you going to print it out to?
The library.
Yeah, but you're going to have to pick it up between classes because I don't think you're going to have time to go and get it because we're almost to the last 5 minutes.
I'll just do it in my head.
Okay.
It's the last one. So I could be back in 3 minutes.
Okay. Go for it. Better be back in 3. Hopefully the bathroom's open. All right, ladies and gentlemen, go to work, go to work, go to work.